Okay, Chapter 2, review sheet for the test. Now remember that on this review sheet, when I made it up, the concepts are the same on the test. So as long as you know these concepts, don't memorize answers because it's not the exact same questions but the concepts. So let's go through them one by one. When you have your test, what I recommend, because your FRQ paper is blank on the back, when you're doing the test, put the test like this, put the back of your FRQ paper so you can work each one step by step. Alright, so number 1 says if a car is traveling an average speed of 60 kilometers per hour, this says average speed, how long does it take to travel 12 kilometers? So we know that speed is equal to distance over time. And that's all we have to do. So the time is equal to the by 60 is equal to 0.2, so the answer is A, 0.2. Now, what if you messed up your equation and you did the reverse? You did 60 divided by 12. Do you think that's going to be one of the answers? Divided by 12 is equal to 5, and that's one of the choices. Whatever standardized test you take, whether it be this physics test, whether it be an SAT 2 subject area test in physics, whether it be the ACT, whatever the most common error is, that's going to be one of your choices. You're going to be like, oh yeah, I got the right answer. So you just need to be aware of that. Number 2 says a runner completed the 100-meter dash. So again, this is going to be my distance. In 10 seconds, her average speed is, so the speed again is just going to be the distance, which is 100 divided by 10, and you could do that in your head, and the answer is 10. Number 3, a truck with an initial speed of 12 meters per second, so that's my initial speed, VI, accelerates uniformly at 2 meters per second, so A is 2 meters per second squared, for 3 seconds. That's the time. What is the total distance? So I want to find x. So there's my 4 variables. So I'm going to use the equation x is equal to VIT plus 1/2 AT squared. So VI is 12, so it's going to be 12 times 3 plus 1/2, 2 times 3 squared. So when I do it on my calculator, 12 times 3 is 36, 3 squared is 9, times 2 is 18, divided by 2 is 9. I don't even need the calculator, and that's 45. Most of the time, these questions, you could do the math in your head. Number 4, an object is uniformly accelerated from rest, so that means VI is 0, to a speed of 25 meters per second, so that's VF, in 10 seconds. What is the acceleration? So I want to find A. So there's my 4 variables. Which equation has those 4? VF is equal to VI plus AT. I always rearrange the equation to solve for the unknown in terms of the known. So VF minus VI over T is equal to A. So it's going to be 25 minus 0 over 10. Again, 25 divided by 10, I can do that in my head, is 2.5. Don't even need a calculator. Number 5, 2 unequal masses falling freely from the same point above the Earth's surface would experience the same acceleration. Remember, it's the acceleration due to gravity, negative 9.8 meters per second squared. That's a little g. Number 6, as a body falls freely near the surface of the Earth, its acceleration remains the same. Again, that's little g. And we saw the video on the moon with the feather and the hammer. Number 7, which graph best represents the motion of a freely falling body? Now, what you need to do is you have to first say, what type of graph is this? So this is a speed versus time graph. So on a speed versus time graph, the slope is the acceleration. So now they ask me which graph represents the motion of a free-falling body. Well, the slope is the acceleration, and the acceleration is going to be little g, and we know that this is going to be constant, so it has to be a straight line. So right away I'm going to eliminate my curves. This shows a constant speed. So remember, on a speed versus time graph, the slope is acceleration. This shows a zero acceleration. So this is my correct answer. Okay, let's go to the other side. Number 8. It says a 4-kilogram rock and a 1-kilogram stone fall freely. I forgot to write the answer choices here. This was C and this was D, even though I circled them. A 4-kilogram rock and a 1-kilogram stone fall freely from rest from a height of 100 meters. After they fall for 2 seconds, the ratio of the rock's speed to the stone, well, they both accelerate at the same rate, so it's just going to be 1 to 1. So some people might call that a trick question. Remember, they accelerate at the same rate. Number 9. The graph at the right represents the relationship between the distance and time for an object moving in a straight line. According to the graph, the object is. So on a distance versus time graph, first of all, we notice one thing. This is a curve. And we know that a curve means that there's acceleration. Okay? Now this is positive, so it's accelerating. It's not slowing down, so that's why it's D. And these are both completely wrong. Number 10. Which graph represents an object moving at a constant speed for the entire time interval? So first we have to say, what kind of graph is it? It's a distance versus time graph. So first of all, I'm going to look at this and say this represents acceleration. So I'm going to cross this one off. Okay? Now this one, it's a distance versus time graph. It's moving at a constant speed. This is a horizontal straight line. On a distance versus time graph, the slope is the speed, and this shows that it's 0. So that's wrong. This one is constant, but then it becomes 0, so this one's wrong. So this is the only choice here is D. Number 11, the distance time graph at the right represents the motion of a laboratory cart. According to the graph, the cart is, well, if you're not sure with numbers, remember the slope is the same on any 2 points here. So the slope is the same, and on a distance versus time graph, the slope is going to be the speed, so when I can see it's moving at a constant speed. D. Whoops. All right, let's go to the next page. I printed mine larger so it would be easy to see instead of the tiny one I gave you. So I put the graphs on the test because I thought everyone had a pretty good understanding of them. All right, so number 12. Base your answers to the following question on the graph below. Which shows exactly the velocity of a 1,500 kilogram car during the 20-second interval? So it starts off at 0 and it goes to 20 seconds. So it says during the time interval CD, so this is CD, the average velocity of the car is, now this is not a distance versus time graph. So a lot of people, the most common mistake is people are going to take the slope of the line and say that's the average velocity. But it's not a distance versus time, it's a velocity. So the average velocity is average. The velocity here is 10. The velocity here is 25. So 10 plus 25 over 2, that's my average. So 35 divided by 2 is going to be 17.5. So a lot of people get that question wrong because they think it's the wrong type of graph. Okay, the next graph, it says, base your answer to the following question on cars A and B. They both start from rest at the same location. Compared to the speed of car B at 6 seconds, the speed of car A at 6 seconds. So here's 6 seconds. Car B is up here, it's 10, and car A is 8. So it's going to be less. Car A is less. So remember, car B is 10 meters per second, and car A is 8 meters per second. So this one, you just have to look at the graph. You don't even need to be in physics to answer that. All right, next one. Now, I've only got 2 left. The graph at the right shows the relationship between the speed and time for 2 objects, A and B, compared to the acceleration of B, the acceleration of A. So first thing you're going to do is say, what type of graph is this? This is a speed versus time graph, and the acceleration is the slope. So what's the slope of this? I'm not really sure, so I would calculate them. So A, I would go from here to here. It's going to be delta y over delta x. So I'm going to say, I'll do like this point. So I'll say 15 minus 0 over 2 minus 0. So 15 divided by 2 is 7.5. And then for B, because I see that this one's steeper, but I don't know if it's like twice or 3 times. And then B, I'll take these points. So I'll say 10 minus 0 over 4 minus 0 would be 2.5. So 2.5 is going to be 3 times. Sometimes it's easy to see. Sometimes you might actually have to calculate it. Because I wasn't sure if it was 2 times. Was that one of the choices? Yeah, twice is great. Last question. Which graph best represents the relationship between the acceleration due to gravity and the mass for an object near the Earth? So this is an acceleration versus mass graph. So again, this has, regardless of the mass, as the mass increases, is the acceleration going to change? No, it's the same. So this would be constant. So that's why this is the answer. Remember, regardless of the mass, the acceleration is going to be the same when we drop something. And that's it.